Okay, welcome back to this topic, which was the conformational analysis of substituted cyclohexane systems. Remember last time we have seen the energy variation in a cyclohexane system. Cyclohexane, just to repeat, cyclohexane exists in the mainly in the chair conformation, and there are again extreme conformations like which is the boat conformation that was told by Sachse and Moore, but then it was realized that this boat conformation is not a conformer. What is a conformer? Is what is called a twist boat. Okay. But in most of the cases, it is the chair conformation which is the predominant form. So, in our discussion, this boat or twist boat will come very rarely. Now, we also have seen that what is the energy, how to calculate the energy of the boat form over a anti-butane unit. The anti-butane unit is regarded as the 0 point energy and the starting point, and then from above that, if something is unstable than that, then you try to calculate the energy on the basis of what are called the butane interactions. Butane interactions can be of three types. Anti-butane interactions is regarded as 0, there is because the two methyls are just exactly opposite to each other. So, there was no torsional strain and there was no steric strain. So, nothing is there. So, it is regarded as the 0 point energy. Now, as the dihedral angle decreases, then they increase there will be increase in energy. Okay. And accordingly, we have identified methyl hydrogen eclipsing interactions, then methyl then gauche butane interactions, where the two methyls having a dihedral angle of 60 degree. Okay. Gauche butane is unstable with respect to anti by an amount of 0.9 kilocalorie per mole, and based on that we have regarded cyclohexane as consisting of 4 butane units 6 butane units 1, 2, 3, 4 and then 2, 3, 4, 5, then 3, 4, 5, 6, then 4, 5, 6, 1, 5, 6, 5, 6, 1, 2 and then 6, 6, 1, 2, 3. Okay. And then after that you come back to that 1, 2, 3, 4. So, these are the 6 1, 2, 3, 4, 5, 6 butane units that you can think of present in a cyclohexane, and all these 6 butane units are in the gauche form that I have told you. So, that becomes an energy of 5.4 kilocalorie per mole. Okay. And then the boat form, as I shown, in the boat form there are on the contrary 4 butane units which are in the gauche conformation, and there are 2 butane units which are in the eclipse form. So, the eclipse form has higher energy than the gauche form. So, 2 eclipse forms adds quite a large amount of energy, and along with that there is another kind of interaction present in the boat form, and that is the interactions between these flag pool hydrogens. So, that makes the boat unstable. I think we have covered this thing. Then we went to the conformation analysis of disubstituted cyclohexane. Now, in disubstituted cyclohexane, the first one that we have covered, the first one was that you have a R1 and you have R2. Okay. So, disubstituted cyclohexane exists in the chair form, but by inversion you can get the other chair form. And what is the difference between these two? R1, see in inversion again in flipping, you should remember in flipping the axial becomes equatorial, equatorial becomes axial, but the alpha beta nature remain the same. So, this is the situation R1 R2. R1 has become equatorial. Now, which one will predominate? That will depend on the size of R1 and R2. The rule of thumb says that the bigger group always occupies the rule of thumb says that bigger group occupies the equatorial position, in order to avoid the interaction which is called 1,3 diaxial interaction with the axial group. Okay. So, the bigger the group, this interaction will be more. However, I gave you an example you should, when you go through this presentation, you will see that this, in case of R1 equal to methyl and R1 equal to phenyl, it is the phenyl that preferentially occupies the axial position, and I have given you the reason for that. Okay. The next is the substitution. There is not 1 substitution which are 1 2, and I quickly go through what we have done. We have done the, see the way to do it. First you draw a planar formula where there is a methyl here. Suppose we take 1,2-dimethyl cyclohexane. So, there will be a methyl, because now we have the possibility of cis and trans isomerism. How? Because this methyl can be beta and the other methyl also can be beta. There is another isomer where one methyl is alpha and the other methyl is beta. Okay. So, when we did this analysis was done last time. When we did this methyl, see how to do it. Now, you convert it into the chair, you write the chair form. Suppose this is your number 1 carbon, this is number 2, 3, 4, 5, 6. So, this will be your 1, 2, 3, 4, 5, 6. Okay. So, let us see. At 1 you have a beta methyl group. So, to make the beta group, you have to make it axial. I think with practice you will be immediately, you can, it will be easier for you to write this. So, how do I do it? I know that the axial group here is beta and I required a beta methyl. So, I put the axial, the methyl has to be axial here. At 2 position, again the methyl is beta and the 2 bonds, amongst the 2 bonds, the equatorial bond is beta. So, I have to put the methyl in the beta position. Okay. So, this is hydrogen, that is hydrogen. Then what I did? I said that okay, you can flip it, and if you flip, what will happen? This methyl will be here, that is the number 1 methyl, and this methyl will now be on this side. Okay. So, this is 1, 2, 3, 4, 5, 6. Then an interesting thing came, an interesting concept. The interesting thing about these 2 molecules, 2 flip forms, is that this is the mirror image. Their relationship between these 2 are mirror images. Now, I gave you a mnemonic device to compare this and that. Remember that I gave you a mnemonic device which was that you go from, you pick up a particular direction, that I will go from an axial methyl group to an equatorial methyl group, okay, while traversing the entire cyclohexane molecule. While doing that, axial to equatorial I do for both the molecules, and then I see what will be my beta alpha relationship and what is the direction that I take. So, beta alpha relationship is beta, you are going to beta to a beta, no problem, but the direction you see, ultimately the direction is a clockwise direction. Here you will do the same thing, axial to equatorial. Now, you have beta to beta, beta axial to beta equatorial, but the direction you see is now anti-clockwise. So, if I said that this is always same, because that is fixed, prefixed by you. The other 2 parameters, if both the parameters are same, then the systems, 2 systems are same. If one parameter is different, then they are mirror images of each other. If both the parameters are different here, then again they are back to the same molecule. Okay. Now, this is a mnemonic device. You can say that, sir, why can't we in other ways, just to show that this is the mirror image of the other, why can't we rotate this molecule and try to bring it to the similar looking molecule. Okay. So, today I will do that. See, when you have a chair form, like this, suppose this is the head carbon and this is the, so this is my chair. The starting chair is this, if you can see it. So, this will be my head, the head of the chair, and this is the leg of the chair. Okay. Now, this has got a C3 axis around this. So, if I rotate the molecule by C3, if you rotate the molecule by 60 degree, you see earlier the chair was, the head of the chair was on this side and the leg bottom of the chair was on this side. Now, the head of the chair is here and the bottom of the chair is here. So, by 60 degree rotation you have changed the appearance of the chair form. Now, if you do another rotation, that means 120 degree, you see I come back to the head on the tops on this side, right side, and leg on the left side. Okay. So, you do it constantly. So, the chair, if you do 60 degree, chair constantly goes from one form to its mirror image form. So, basically what I am saying, that if you have a chair like this, okay, this is really conceptual. If you have a chair like this 1, 2, 3, 4, 5, 6, and if I start rotating it into the clockwise direction, suppose I do it in around 60 degree, then the chair will not look like this, the chair will look like this, mirror image chair. The question is which group has gone where. Okay. So, now see, one can never be at the bottom carbon, right. One is always 1, 3, 5, where at the top carbons. Okay. So, what happens here? Now, you have pushed the whole thing 60 degree. So, you have 5 here and this is your 6 and this is your 1. So, these are the positions. So, 1 will come at this position and I will just again explain it how to completely visualize it. Okay. So, initially when you have started, your 1 was the head and 4 was the tail of the chair or leg of the chair, whatever, leg of the chair. Okay. 1 head, 4 L. Now, what you have? 3 head and 6 leg, 3 at the top, head of the chair, and 6 at the leg of 3 at the top of the chair, 6 at the leg of the chair. Okay. Now, if you do another 60 degree rotation, the chair should look like the original. Question is which one is where, which carbon is where. So, you have rotated it now, you have just again rotated it by 60 degree. So, what will happen now? Now, your 5, see earlier what happens, 1 was at the top. So, next was 3 at the top. Now, the third time it will be 5 at the top, because these are the 3 top groups, 5, and then this is the 6th group, this is 1, this is 2, this is 3, this is 4. Hopefully, this is okay. So, when you rotate it by 60 degree, then what happens? 5 goes to the head of the chair and 2 goes to the leg of the chair. So, now it is 5 head and 2 leg. Okay. C2 at the leg position. So, this way it happens, means this is the way. So, 1 and 4 were the head and the leg, then it was 3 and 6 and finally. So, this keeps on jumping by 2 units, 1, 3, 5 the head and the leg also 4, 6, 2. Okay. So, you can do it like this and complete the rotation. Okay. You see the complicacy, that is why I gave you the mnemonic device, but you should also understand the basics of it, if you rotate it. So, if I start rotating this now, the same thing, suppose I rotate this by 60 degree. So, what was 60 degrees? The chair will form this form, take this form, okay, the mirror image form, and where will be 6 now? The 6 will be still here and 1 will be here, 2 will be there, 3 will be here, 4 will be here, 5 will be there. Okay. So, 1 equatorial is this and 2 axial is this. So, now look at these two. Are they mirror images of each other? No, not yet, because this chair is not the mirror image of this chair, they have the same chair. So, in order to do that, you again turn it So, this was turned by 60 degree. So, now you turn it by another 60 degree. So, what will happen? The chair will take a form which will look like this. Now, which will be the bottom carbon now? The bottom carbon is the 5 here. The bottom carbon is the 5. Okay. So, 5, then this is which one will be the top carbon? The top carbon will be the 2 carbon, and this is the 1 carbon. Okay. So, as I said earlier, it was 3 6 3, now it will be 5 2 system. So, 5 2 is there, and then you put the groups. So, at 1 there is the methyl, and 2 there is the methyl. Okay. So, now you see the relationship between these two. This is exactly the mirror image of that. Okay. But you have to come all the way after rotating this. Now, it is up to you whether you use the mnemonic system, or if you look at the by rotation you can come out to the same conclusion, that by flipping you get the mirror image of the original form. So, what I said that day, that this molecule cis 1,2-dimethyl cyclohexane exists as a non-resolvable DL pair. It is chiral, but it exists as a non-resolvable DL pair. Why? Because this is the moment you try to isolate this, 50% of it will go to this form, because these two forms are mirror images and they have the same energy. Okay. So, and because this is done by flipping, flipping is always going on at room temperature. So, it will not be possible to separate under ambient conditions. Okay. Again the question comes, if you lower the temperature to a very low temperature, to a very low condition, then possibly they may, this flipping you can slow down. So, if you can slow down flipping, then it is possible to separate them. Otherwise, under normal conditions they are not separable, because this flipping is continuously happening. So, these cases are called, these are non-resolvable DL pair systems. Another terminology you can introduce, non-resolvable DL pair systems, or you can call it conformational enantiomers. They are conformational enantiomers. So, usually what happens, the enantiomers that we know, to go from one enantiomer to the other, you have to break a bond. By rotation you cannot go from one to the other, but here these enantiomers, they are enantiomers definitely, but they cannot be resolved. Why? Because one goes to the other simply by rotation, by flipping, and that is why they are called conformational enantiomers. Okay. So, we have seen that now how to rotate and get to the original position. In case of 1,3 system, 1,3 system means, okay, first draw the planar structure. So, this is methyl. Suppose I want the cis compound, this is methyl. Okay. So, in 1,3 system, this is again, this has to be put in the, this is 1 2 3, because both are beta. So, this is beta and this is beta. So, this is one conformation, but looks to be very unstable, because both the methyls are in the axial position. So, you have lot of interactions now between methyl which is huge, which is a very high amount, then you have methyl hydrogen and then this methyl hydrogen. So, this will be really unstable, and what it flips into, the flip form is quite stable. This carbon comes here, so that will be here. So, that is your 1 2 3. So, this carbon comes here, and this carbon is at the 3 position. So, that will be there. So, there will be a huge difference in the population between this and that. The molecule mostly exists in this form, because this is so unstable. Okay. You can calculate, like the earlier one, you can calculate the energies that are associated with these systems, like you calculate the methyl as the axial. So, that introduces 2 gauche butane interactions. So, this methyl puts 2, this axial methyl puts 2 gauge butane interactions. In addition, you have this methyl which has to be counted here, methyl. Okay. So, that gives it a much higher energy than this form. What about the optical activity? The optical activity, you do not have to draw the way to do it, either you, if you see any plane of symmetry or center of symmetry, those type of elements, then you can immediately say it is optically inactive. Okay. Which is, you can see that if you bisect this, so this becomes a plane of symmetry. This becomes a plane of symmetry. Interestingly, that plane of symmetry is also visible in the planar form. That plane of symmetry is visible in the planar form. Okay. So, this molecule is optically inactive. So, no question of checking the optical activity, optically inactive. Okay. Now, the next one is the trans isomer. The next one is the trans isomer. So, you make one of the methyl as the alpha. So, immediately this is gone, right, this plane of symmetry is gone. So, you write the conformation. So, this is beta, this is the methyl 1 and this is 2, this is 3. So, 3 is alpha. So, methyl is here, hydrogen. So, now this is an interesting situation, more interesting than the cis one. The trans one, now you can flip and they will have the same energy in the trans one, because in both the cases one will be axial and the other will be equatorial. So, if we flip, this methyl becomes beta equatorial and this methyl becomes at the 3, that becomes beta axial. Okay. Now, the question is, by flipping what we get? There is no energy difference between the two. So, in the system we expect that there will be 50-50 mixture of these two, provided they are different, because there is a possibility that they are same. Okay. Now, to check whether this is same as this or this is mirror image than that, remember your cis 1,2 dimethyl cyclohexane, flipping gives the mirror image and that makes it a non-resolvable DL pair. So, it is the same thing happening in trans 1,3, that is the question. Trans 1,3, what is the optical activity? Does it remain as a DL pair which is separable or non-resolvable? So, in order to know that, you have to know decide the similarity between this and that. Now, it is up to you what you have to do. The mnemonic device you can apply. So, if you apply the mnemonic device, now what is happening? Suppose I go to axial to equatorial, the same one that I did for the cis 1,2. So, axial to equatorial, that means I am going from here to there. Okay. So, then I check the alpha beta. Where is the alpha beta? The axial to equatorial, this is beta. So, I go from a beta to a alpha, and in this case what I do, beta to alpha, I am going from axial to equatorial, I go from alpha to beta, a change. Okay. And the third one is the direction that I did go from here to there. So, that was clockwise and I went from there to there. So, that is anti-clockwise. Basically, I am traversing the whole chair system through the shortest possible path. Shortest means the shortest connectivity between the substituents. Okay. So, that is anti. So, now again you check these 3 parameters. This is always identical, because that is your prefixed. You have decided to take it from axial to equatorial. You could have done the other way around, equatorial to axial, but then you have to do for both. Okay. So, this was same, I have fixed it. Now, you see these two both are different. I told you in this mnemonic device, if one is different, then that becomes mirror image of each other. If two are same, then that they are same. If two are different, then also they are same. Okay. Then also they are same. A very interesting thing that you can say is that how they are same. I can tell you that if you change your reference plane, see this alpha beta is basically based on the reference plane, that these average plane of cyclohexane, based on the average plane of the cyclohexane. So, what you do here, if I change my reference plane, that I think that this the down because I am my direction is from the top. That means, I am looking from this position, thinking that any group which is below this plane becomes beta, and any groups which are above, which are towards me, they are alpha. They are, so my reference plane I have just changed, because I myself have changed. It is the other world that we have a vertical world like this. So, it is the other world that I am looking from the top, and I change all the references now. The groups which are away from the plane going bottom are the beta, and those which are lower than that plane will be alpha. So, if I do that, if I look from that and change my reference things, axial remains as axial, equatorial remains as axial, and the problem is the alpha beta. Now, the alpha becomes beta according to the new convention that the lower groups are beta, and this becomes alpha, because my reference is now just the reverse. I say that all the down groups are beta, up groups are alpha. Then if I do that, so beta becomes alpha, alpha becomes beta, and the direction was earlier anti. So, now the direction will become clockwise, because I am looking from the top. As I said, any direction looking from this looks clockwise, but if somebody looks the same from the top, it becomes the other way around, anti-clockwise. So, now it will be clockwise. So, you see now the 3 parameters are same. So, without going into the complexity, what I said, that if you see the 2 parameters of these are same, then all the 3 are same basically, then the 2 things are same. If one of the parameter is different, alpha, beta or anti direction, then they are mirror images of each other. If both are different, then they come back to the similarity issue. Okay, they become similar. So, in this case, ultimately what is the conclusion? That these 2 are same molecules. So, flipping here does not give the same molecule. So, then you take the mirror image. So, at least if next question is whether it is chiral or not. So, you take the mirror image, not this way. Suppose I take the mirror image this way. So, I get this, the methyl is here and this methyl is here. Apply your mnemonic device that I have given you. Now, whether this mirror image is same with this, what you do? You go from axial to equatorial, then it goes from beta to alpha, and the direction is anti-clockwise. So, direction is anti-clockwise. Okay. So, here I have already erased those things. Here it was axial to equatorial, beta to alpha, and this is beta to alpha, and this was beta to alpha, that was clockwise. Okay. And this flip form, now you forget, because this is the same as that one. The question is between these 2. So, if you now check the relationship between these 2, what you are saying, this is identical, only this is different from this. So, they are non-superimposable mirror images. So, what does it mean? That means these are optically active. Now, the question is, can you separate them? Yes, they are separable, because here, unlike the situation in cis 1,2 dimethyl cyclohexane, here flipping does not give the mirror image. Here, this by flipping it goes to itself, and this mirror image also by flipping, mirror image has also the ability of flipping. Mirror image by flipping also will remain in as the mirror image. Okay. So, these 2 are separate entities, these 2 are not, and here the flip form of this and the original one of the mirror image, they are not. Okay. These are same, but these and these are not same. Okay. So, now the final conclusion is cis 1,2 dimethyl non-resolvable DL pair and trans 1,3 dimethyl resolvable dual pair. Okay. And I hope you have understood what is the basis of this. Okay. So, to check all this chirality in these systems, you have to flip and you have to check the mirror image and see the similarity between all these three systems. Then you can come to a conclusion. Okay. Thank you.